myself Rohini Mergu, talking about the antenna gain measurement part 2. Learning outcomes: at the end of this video you will be able to measure the gain of the antenna using 2 antenna and 3 antenna method. I have prepared the video of the antenna gain measurement by direct comparison method also. You can go through this with that video also, and this method of measurement is using 2 antenna and 3 antenna method. So basically there are 2 standard methods for measuring the gain. One is the gain comparison method or direct comparison method. Another is the absolute gain method, which is 2 antenna and 3 antenna method. So this video is about the absolute gain method. What is meant by the standard antenna? So as I said that I have prepared the video on the absolute gain method. As I said that I have prepared the video on gain comparison method. So in gain comparison method we use the standard antenna. So what is that antenna? So the standard antenna is the antenna whose gain is accurately known, and it can be measured by can be used for measurement of the gain of the another antennas. The standard gain antenna is the horn antenna, which is used at microwave frequencies from 300 megahertz to 300 gigahertz, which is used as a standard gain antenna, SGA. Now in the absolute gain method, what is this method? Let us try to understand. As we have discussed, the standard gain antenna is the one whose gain is already known or calibrated. But if we want to calibrate the gain of the antenna whose gain is unknown, so that can be done by using 2 or 3 arbitrary antennas. Suppose the 2 antennas transmitting and receiving are separated by the distance r, and if their transmitting power is Pt and received power is Pr, then and if I consider the effective transmitting area as AET and effective receiving area as effective aperture area EER, so in that case, effective aperture area of transmitting antenna and if the effective aperture area of receiving antenna, if these are equal, I can say that I am using 2 identical antennas for absolute gain measurement. And the figure shows the arrangement of the 2 antenna method. Here you can see 2 antennas whose effective aperture areas are same. In the one is acting as a transmitter, other is acting as a receiver. I can say this as a transmitter because here I am using the detector and the power bridge, and here it's a attenuator pad receiver. This is the receiving section and this is the transmitting section of the antenna. In this method, the 2 antennas which are identical are used and its effective apertures are equal. The effective aperture formula is G naught lambda square by 4 pi. As we know, the Friis formula, that is the power received upon power transmitted, can be given as effective aperture multiplications of transmitter and receiving antenna divided by lambda square into r square, where r is the distance between the transmitter and the receiver. And if I substitute this effective aperture value in this equation, I'll get this equation like this. So G naught lambda upon 4 pi comes twice because effective aperture of transmitter as well as the receiver. So thus if I simplify, and I can get that PR under root PR by PT as G naught lambda upon 4 pi r, or as I am interested in the gain, I can simplify and I can get G naught as equal to 4 pi r upon lambda under root PR by PT. So here in this equation we have not considered the effect of the direct and indirect rays and the ground reflections. If we consider that effect, that f, the factor need to be added in my equation or need to be considered in the equation, that f is called as a propagation constant. So I get G naught as 4 pi r upon lambda f under root PR upon PT. Now how we have obtained the gain, that I can talk about from this equation as by knowing or by measuring the received power, by measuring the knowing the transmitted power, by knowing the distance between the transmitter and receiver, and by knowing this f, the factor. So by knowing all this, I can calculate G naught, and this G naught is the gain of the either antenna. So G naught is the gain of the either antenna which we wanted to determine. This is the 2 antenna method. So gain can also be expressed in decibels. if we want, and then we can also calculate the gain by this method, because we know all these factors PR, PT are as 10 log. So this method of two antenna is okay, but in most of the cases it is not possible to have the two identical antennas. We may not get the antennas which have same effective apertures or equal effective apertures, so it's not possible practically all the time to have two identical antennas. So there is another method which is called as a antenna method, where measurement is done by the three antennas. If I assume the antennas as A, B and C and their gains as GA, GB and GC respectively, and if I consider that I have used the transmitting antenna as A and receiving antenna as B, then the power fed to the transmitter is called as PTA, because for A antenna, and received by the B antenna, so it can be PRB. And if I assume that the distance between transmitter and receiver is R, so in that case I can write GA plus GB is 20 log 4 pi R upon lambda plus 10 log PRB upon PRA. This is the equation of the gain, addition of the two gains of the transmitting as well as the receiving antenna gain. Similarly, I can consider transmitting antenna A, but receiver is now changed to C. Now again I will write the same equation. Here GA, instead of GB there is GC, and the equation is same, but here as receiver is antenna C, it comes to be PRC. Now I'll change the transmitter, I'll keep the same receiver. Receiving antenna is C, the transmitter is B. So here addition of the gains will be GB and GC. As transmitter is changed, here transmitted power will be PRB and receiving is PRC as it is. So by knowing these three equations and by substituting these values, I can get the gain of the unknown antenna. How? That we'll see. By substituting the measured powers, distance R, by knowing the wavelength, and by solving the three simultaneous equations, there will be three unknowns. These three unknowns are nothing but the three gains, and by solving them, I can get the required gain. Let us see here. Like this is the equation 1. Let us say this is equation 2 and equation 3. If, for example, I want to find the gain of the antenna A, so what I'll do is, I'll subtract the equation 2 and equation 3. When I subtract 2 and 3, as you can see here, GC cancels out. I get GA minus GB on the left hand side, and this GA minus GB can be added, or the resulting equation will be the equation 4, and that equation can be added with the equation 1. When I add it with the equation 1, again GB plus here, GB minus here will get cancelled. I'll get twice of GA is equal to the RHS side, and I can divide the RHS by 2 so as to get GA. So just by solving these three simultaneous equations, I can find out the gain of any antenna A, B or C. But there can be errors in the measurements in the absolute gain method also. There can be the errors due to the misalignment of antenna. There may be the error due to polarization or impedance mismatch between the transmitting and receiving antenna. Can be the errors due to the test field imperfections. Field imperfections means there should not be any obstacles in the measurements while we keep the transmitting and receiving antenna. There should not be a free space between them. These are the references used for preparing this video.